I welcome you all for this lecture series on artificial intelligence and machine learning. In this presentation, we'll explore how AI and machine learning systems must operate in environments where data is incomplete or uncertain. The topic is especially important in fields such as autonomous driving, where vehicles need to make decisions based on unclear or unreliable information. Through the case study of autonomous vehicle, we will explore into the various uncertainties that AI system face and how they manage them to make safe and effective decisions. And as I said, the case study, what we are going to see is autonomous vehicles. The autonomous vehicles are an ideal example of AI systems that must navigate uncertainty. These systems rely on data from various sensors to understand their environment, but the data is often incomplete or noisy. By focusing on autonomous vehicles, we will discuss the role of uncertainty in AI and the strategies used to handle it. First, we'll see the introduction to uncertainty in AI and ML. What is uncertainty? In AI ML, uncertainty refers to the lack of precise knowledge that can influence a system's decision making process. There are two main types of uncertainty that AI system faces. The first one is aleatory uncertainty. This refers to randomness or inherent variability in the system, such as unpredictable sensor data due to external factors, say, for example, weather, signal noise, etc. This type of uncertainty is intrinsic and cannot be eliminated, only managed. The next type is the epistemic uncertainty. This is caused by the lack of knowledge or incomplete information, often due to limitations in the models, sensors, or training data. Epistemic uncertainty can potentially be reduced as more data or better models become available. The relevance of these uncertainties are in applications like autonomous vehicles, uncertainty plays a significant role. These vehicles must make decisions in real time with limited or noisy information. Uncertainty makes decision making more complex because why it is more complex? Because the system must weigh the risk of various actions in unpredictable situations. Understanding and managing these uncertainties is crucial or important for achieving safe and reliable systems. Next, autonomous vehicles and uncertainty. The example is an autonomous vehicle and uncertainty. The first scenario is autonomous vehicles which are designed to navigate safely without human intervention face various types of uncertainty while operating in real world environment. For example, when an autonomous vehicle approaches an section, it needs to make decisions on whether to stop, slow down, or continue based on sensor inputs. So, uncertain inputs. What are all the uncertain inputs? Sensor data. Autonomous vehicles rely on multiple sensors, including LIDAR, radar, and cameras to detect obstacles, pedestrians, and traffic signals. However, these sensors are not perfect. For instance, radar signals might be distorted by weather conditions like fog or rain, and camera images may be unclear due to poor lighting. This leads to aleatory uncertainty where the data can vary randomly. And what would be the environmental conditions? Beyond sensor noise, the vehicles also has to deal with the real world factors such as the sudden appearance of pedestrians or other vehicles in the path. These events are epistemic uncertainties where the vehicle cannot always predict the action of other road user accurately. And the types of uncertainty, what I have said, aleatory and epistemic. For example, a random movement of pedestrians or other vehicles or influences in sensor reading that might lead to different interpretations of environment. Next, epistemic. This comes to into play when the vehicle has incomplete knowledge about current situation, such as not knowing the intentions of pedestrian, whether they will cross the street or the status of traffic light, whether it will change soon. Next approach is acting under uncertainty. Probabilistic decision making. How we are going to face these problems? How first probabilistic decision making. In this, AI systems must be equipped with methods to handle uncertainty. Probabilistic decision making methods are central in this context. First, Bayesian interference. This approach allows the vehicle to update its belief about the world based on new evidence. For instance, if a vehicle sees a pedestrian appearing the crosswalk, Bayesian interference can help update the probability that pedestrian will cross. The system continuously recalculates these probabilities as the new data is collected, make decisions based on likelihood on different outcomes. Next, Monte Carlo methods. Autonomous vehicles use Monte Carlo simulations to simulate multiple possible outcomes of a situation. For example, it may predict the movement of pedestrians or other vehicles based on observed behavior. These simulations help the vehicle anticipate a range of possible outcomes and make decisions that reduce the risk of accidents. Next, reinforcement learning. AI systems, particularly in autonomous driving, can learn from their actions by interacting with the environment. If we are in a reinforced learning framework, the vehicle learns to act optimally by adjusting its behavior over time based on the feedback it receives from its environment. That is example. What is the example? Whether its action leads to safe or risky situation. For example, the vehicle might learn to slow down when approaching a crosstalk if it notices that pedestrians often crosses their unpredictability. And coming into the conclusion, this we are seeing it as importance of acting under uncertainty. The first one challenges. Acting under uncertainty presents several challenges. First, autonomous systems must make decisions rapidly, often with incomplete or noisy data. Second, the vehicle must balance safety, that is, example, avoiding accidents with efficiency. Example, maintaining speed and minimizing delays in dynamic and uncertain environment. This becomes even more complicated when multiple uncertainties exist simultaneously. And what would be the impact? Effectively managing uncertainty is key to success of autonomous system vehicles. By incorporating techniques like such as Bayesian interference, Monte Carlo simulation, and other reinforcement learning, autonomous vehicles can make better, more informed decision making in real world scenarios. Handling uncertainty correctly ensures that these vehicles can operate safely and reliably, even in fact of unpredictable situations like sudden obstacles or unclear sensor data. So that's all about uncertainty and of acting under uncertainty. In this case, we have seen autonomous vehicle as the example. Coming into the conclusion that in AI and machine learning, acting under uncertainty involves making informed decisions despite complete or noisy information. Probabilistic models, Bayesian interference, Markov decision processes, and reinforcement learning enable AI systems to balance exploration and exploitation while accepting the dynamic environment. Incorporating uncertainty management improves model robustness, enhances decision making, and reduces the risk associated with unforeseen outcomes. As AI systems grow more complex and autonomous, addressing uncertainty effectively ensures reliability, safety, and optimal performance in real world applications. Hope everyone understood this topic acting under and uncertainty. The remaining things we'll discuss in the next class. Thank you.